All right. So, is this working? Yeah. Okay. So, this talk has about a bunch of buzzwords here in the title: moving fast, reducing risk, and of course, as any cool talk these days, LLMs. And so, I'm going to try to demystify the buzzwords in the titles in the next two slides, and then I will talk about our approach. I've also, knowing that this is the last talk, and I'm in between you and the booze, I'm very simple, very light on details, so we can always talk after the talk. So, moving fast, risk and quality. I like usually to discuss this triangle, which is similar to what Sierra and Colin talked this morning. Just some of the words are slightly different, but the meaning is the same, which is we need actually to monitor all these three things. In my case, what I have here is velocity, reliability, and readability. We cannot optimize just for one. And the cool thing about these three metrics or dimensions is that they bring some tension between them. You can go very fast, but you can actually, if you go very, very fast, most likely you will suffer either on reliability or readability. So you cannot optimize for all of them. The cool thing is to find the right balance. And so this is in a way what I'm treating as productivity, like it's finding a metric over here, and I'm not going to go into those details. There was Kareem's talk, tomorrow Akshay, but finding something that is the right balance here that will help us quantify productivity. Now, the other thing that I had in the title was LLMs and release engineering. So LLMs will come in a second, but for you to understand why I'm talking about release engineering is that at meta scale, continuous delivery actually falls back on the engineer writing the code. So the engineer writing the code actually has the power to ship diffs into production, and so this is actually important. Okay, and now we'll go into the LLMs slowly and why we are using them. So before you understand what we are doing here, let me just guide you through what it means to author code. So as a developer at Meta, you write some code, and eventually you publish that code into a system like this one. And into that system, you have here what some other people call pull requests, change lists at Google. We call these diffs, very creative, but anyways, it's diffs. And then in a diff, you have a bunch of things, such as you have the pull request summary, you have a test plan. Let me explain what a test plan is for us. A test plan is some sort of an enumeration of the steps that you as a reviewer, you need to do in order to replicate the changes. Right? So if you are reviewing the code and you want to go beyond just reading the code itself, you have a set of steps that you should do in order to see those things happening. Then, of course, you have to assign reviewers. There is comments and activity and that sort of thing. Pretty normal, except for the test plan, I would say. But all the other things are pretty, common. Now, what we actually are doing as well is that beyond all these things is whenever you publish a diff, you will see something that will make you risk aware. Something that is somewhat similar to this box. Maybe it's best if you look at these two screens, because here it's not very clear anyways. And so this essentially gives you a sense of how risky your change is. And now once you have this, there are a number of things that you can make. And one of such a things is to deal with code freezes, okay? So there are other scenarios that we can talk afterwards, but the one I'm going to work on this set of slides is code freezes. So the idea is that during critical periods, for example, mega sale events, and in order to ensure the stability and reliability of your code base, you actually do not allow any changes to be pushed into the code base, okay? And so, as I said, this is observed during certain periods of the year. The idea is to suspend the changes, right? So you do not allow anything to land. There are two ways to deal also with this. One is do not allow anything. The other one is actually to suspend for a certain period and then allow on another day. For example, suppose that I want to do a code freeze during weekends because people go out partying and whatnot. Then on Monday I would allow everything that was waiting during the weekend to land. Okay. Now, as you can imagine, that if we are actually preventing changes to the code base to happen, what happens also is that there is an impact on velocity and therefore productivity, right? As if you can recall, the triangle velocity was one of the dimensions of productivity, and so we are directly hitting velocity. We are actually hitting velocity not only during the code freeze, but even after the code freeze. As you can imagine, when the gates are open, you have thousands of diffs trying to land, and of course there are merge conflicts. There are all sorts of mess that you cannot, that you don't want to deal with, right? And so we need ways to actually deal with this, and that's how the LLMs are coming to play. Okay. Now, different ways to deal with code freezes. The first one is the one I was talking about: 100% gating. Nothing happens. You just wait. Then there is another way that is different gating levels. So, for example, you could say that, whether or not the diff is risky, we'll let it go. You don't care, whatever, right? Someone will deal with that later. The other one is, for example, during weekends, we gate at, let's say, the top 5% of the risky diffs. We do not let them go, and we gate them. We can also have this medium impact on end users. Let's say the top 10%. Those numbers are made up, by the way. You can change to the percentage that you want. And then there are like the high impact on end users. Let's say that if this happens, I'm gating 50% of the diffs, and I will let go the 50% less risky diffs, right? Now, for us to be able to do these alternative ways of gatings, then we need something, right, that will tell us how risky a diff is, right? We need a tool that actually will provide us that percentage that we show in the UI, as I was showing you. And that's how then the LLMs are coming to play. Now, I have this slide as a sneak peek. I know that I haven't talked about any of this. I will show you in a second. It's just for you to be curious and about which one works best. So we tried a different set of models. These two ones are the LLMs. The second one is, let's say, it's a language model. Let's not call that one anymore a large language model. It was pretty large at the time, but it's no longer large. The two are large language models, and then there is the logistic regression models, which is, let's say, our baseline. Okay? So essentially what we have observed, and I will go into details in a second, but just as a sneak peek, our baseline regression captures, those are the numbers, 19%, 28%, and 85% of the SEVs. SEVs are outages, are problems, right? While respectively gating 5%, which we say that is the weekend gating, 10%, which we say is the yellow gating, and 50% the red gating, as I explained before, right? So those are the numbers for the regression model. I will go in a second into the details about features and whatnot. And then there is the BERT-based model, which is slightly better than the logistic regression model. And then, as I said, we tried two different types of LLMs. We tried the generative LLM, and I will go into that in a second. This generative LLM is not as much better than the language model, but the risk-aligned LLMs, and I will, again, in a second say what we mean with risk-aligned LLMs, is actually the best performing technique, okay, or LLM or model. Now, let's go into details about how all these models work. I'm not going to talk about the logistic regression models. You know what it is, right? Set of features, predict a score, and that's it, right? So this is what I said anyways. So the BERT-based model is a model that is very simple in terms of what it takes as input to the model. So we take the title, the summary. Actually, the summaries we are not taking into account, so forget about summary there. And I will tell you in a second why we don't use the summary. But title, test plan, the files, the set of changes, we run through that model, which is, again, some sort of language model. And then it comes with that diff embedding, and this diff embedding is then sent into a logistic regression model in order to predict the score. Okay? So this is the BERT-based model. Now, the LLMs, we took two approaches. One is the generative approach. And essentially, in the generative approach, we ask the LLM to actually give us a label, whether or not it thinks it's risky. We use the embedding of the LLM. What is here? No. Okay. Doesn't work, Karim. This is it. So it takes the set of embeddings instead of using a generative, we could ask the LLM to actually come up with a score, and the LLM will come up with a score. Now, what is the problem of doing that? Is the LLM will start hallucinating, right? Saying, I don't know, you want a number between 0 and 100, and says it's 1,000% wrong or risky. And so that doesn't work. In order to get rid of the hallucinations part, what we do is we don't use the generation part. Actually, we stop before that. We get the embeddings of the LLM, and we use the embeddings of the LLM in a logistic regression model. Okay, and with that we compute the score. The other one, which is the risk-aligned LLM, is actually we built a prompt, and the prompt is capable of coming up with a label. When you see a 0 there, I can also not move there, but you see a 0 after in the prompt, right? And so we fine-tune the LLM. That's what we mean with risk-aligned. We fine-tune the LLM to actually output after that DRS token a number between 0 and 1 that actually is the risk score. Okay, and so this becomes much simpler because we don't need to maintain two models, the LLM plus the logistic regression model. And as I have shown you in the results, this is actually the model that works the best. Now, my guess is that you are thinking or asking yourself, okay, what is the set of features? What are these guys using as a set of features? For the logistic regression models, these are the set of features that we are using. So there are things like the lines of code, the new files that are created, whether or not the diff creates new files, whether or not the files in the diff were involved in previous problems, SEVs, even the programming language, a lot of things that actually the LLM can infer. Like the programming language, you don't need to give that as a prompt for the LLM because, well, the LLM will look at the code and will infer that. Whereas, and now this is the cool thing in terms of feature engineering, for the LLM, we only need 3 features: title, plan, and code changes. We don't use summaries. And summaries, there is a reason for us not to use summaries, because summaries is actually a very easy feature to gain, right? And you can trick the LLM to think that the changes are okay by, for example, writing 100 times, this diff is okay, this diff is okay, this diff is okay, right? And so because you can game it, then we don't use it, right? It's very difficult to game test plans because other reviewers will be like, what the heck are you talking about, right? Well, the code changes, you cannot write 100% print this diff is okay, print this diff is okay, but the summary it is. And so we are using those and nothing else. Now, in terms of feature engineering, this is really good because we don't need actually all the complexity of computing these features. We can just extract the features that we have from the system, right? Now, this slide is just to show you one thing. I have the details over there, but actually the message that I want to convey with this slide is that we are actually dealing with, and this is a good thing, by the way, not for the LLM, but for us and Meta, is that we are dealing with an extremely imbalanced data set. SEVs are rare events, and this is good, right? And so, training, fine-tuning these models is extremely complicated. It's not an easy thing to do. Now, because of this, we are actually optimizing for recall, okay? So the numbers I'm reporting are recall numbers, are not precision numbers. Since, this very imbalanced data set, reporting precision will not make much sense. And actually, we have a paper coming out talking about these numbers, and we have the precision numbers, but they will be like 0.8% or something like that, right? They don't mean much, but recall means a lot in this type of data. Again, I have here the data sets for you to understand the samples and where the results come from. I don't think they are very relevant now, except for the message I was trying to convey. And so having said that, and I'm almost done, having said that, these are the results. Again, we split this in 3 different categories, like what we call the weekend or 5% gating, yellow, 10% gating, and the red, 50% gating. These are the recall numbers. Again, I'm not reporting precision here for the reasons I've just said. And overall, the LLM, the 30B LLM, risk aligned, so meaning that we fine-tune the LLM to give us the to compute the score, to give us the score, outperforms all the other models across the board, right? And so this is pretty good in a sense that we don't need all that feature engineering, and we can just go again, as I said, with test plan, summary, not summary, guys, you're right, test plan, title, and code changes. All right, conclusions. I have just discussed with you guys some approaches to code freeze. By the way, we have many other applications of what we call the risk score computation or diff risk score. Many other applications. Here I have discussed just one use case. There are others, such as, for example, recommending reviewers for high risky diffs, right? Auto-accepting diffs that are low risky diffs, and so on and so forth. But anyway, so in these slides and in this talk, I discussed how to use ML actually to deal or to manage code freezes. This will actually improve engineering productivity because it's actually is allowing us to unfreeze some of the diffs, right? We don't need to gate 100%. And so we can just let go, let's say 50%, 10%, whatever is the gating. We have also shown that the use of ML models can actually significantly improve the accuracy of the diff risking score. And we have shown that LLMs are actually very promising. It's not just because it's a buzzword and it's nice to work on LLMs these days, but actually they do something useful here. And it's much better than, as we have shown than the logistic regression, and at the same time gives us the ability not to have to maintain several pipelines to compute all those features, right? And yeah, just a summary of the results, like logistic regression outperformed actually the BERT-based models, but I diff llama 13b, right? So essentially we fine-tuned one of those models that Meta made available to the general public. We fine-tuned for our own purposes, and we have shown that, this model, when risk-aligned, captures quite a lot of SEVs, and we are pretty confident that we can use during code freezes. Yeah, so just to do some marketing here, right? Well, to Karim's talk, you cannot go anymore because it's done. So you can see it online sometime, but you cannot go there. Tomorrow's there is Kelly and Akshay's talk, also on productivity, and as they say, business outcomes and develop happiness. So they will talk about happiness, which is nice. And then there is Adam McCormick also talking about, psychology and that sort of things for developer productivity. Yeah, and there is no Q&A, so you can go to the booths now. Thank you.